Right, welcome back everyone. So in this video, we are going to discuss about the clustering. Now, as I said that the multiple device together, which makes as a one logical unit in order to do the load balancing of your bandwidth. So that's a type of setup is known as a cluster. So now currently you can see that in my topology, I do have two ASAs. One will be the primary and the other one will be the secondary. So if we have more than that one, that should be good. All of them will be the secondary. Next, what my outcome of this lab will be that I want to configure this ASA 1 and 2 in the clustering such that using these two interfaces, you see that these two interfaces, I am going to do a port channeling for that one. So I am, for example, these two interfaces, I do have each interface of 1 GB. So basically that will make 1, 2, and 3 and 4 because I have 4 links going towards the switch. So total bandwidth, I have the 4 GB. So instead of assigning each interface as an IP address or a layer 3, so what I can do is that I can just do a port channeling, aggregate all the 4 links into one link, and that makes me the 4 GB of bandwidth. And now I can use the sub interfaces. I can use the sub interfaces like on the active. Similarly, for example, I will use the port channel 1.1, 1.2, 1.3. So this one will be the inside, this one will be the DMZ, and this one should be the outside. Again, similarly, I am going to assign the VLAN. So point to 1.1, I am going to assign the VLAN of number 2. 1.2, I'm going to assign the VLAN of number 3, and 1.3, I'm going to assign a VLAN number of 4. So that's how it's a good benefit when you have a requirement is for a larger bandwidth. So now coming to this ASA 1 and 2, if you have more than one ASA 4. Now these all 4 ASAs are in a cluster unit which are acting as a, what do we say, logical unit, one logical unit, and within these ASAs there will be a link connected. That link is known as a cluster link. So now this link I have connected directly. You should not connect it directly. So recommendation is that you connect it to the switch always. So now that link is known as a cluster link. And what happens is like now your links have been connected. Now the traffic is coming in. So when the traffic enters into the switch and switch has done its own load balancing and send it to the ASA1. So now this particular session and this particular traffic, ASA1 is the owner. So traffic will be replied back. Next time the traffic comes in and switch has done its own load balancing, and this time it has sent it to ASA3. The first thing what ASA3 will do is that it will inquiry that have someone has any ownership of this traffic or not on the cluster link. And on the cluster link, ASA will reply saying that, yes, I was the one who was owner of that particular traffic. So what it will do, it will forward the traffic on the cluster link to the ASA, and ASA will forward it and ASA will reply it back. So that's how it works on the backend. But you have to do nothing about it because load balancing is done by automatically using the hash algorithms. You need not worry about these things, but you need to know that how the traffic flows. Now, the next thing is that I do have multiple devices. So one will be the primary, which will be known as a master, and all other will be known as a slaves. Now, since you have more than 3, there will be a one more device which will be acting as a director. So this director job is to maintain the database of the ASAs, which are acting as the masters and slaves. And in case ASA2 is acting as a director, in case master goes down, ASA2 is the next in line, so it will not become the master. So it will do the re-election and it will find out who will be the master. For example, ASA3 has become the master. So it will go ahead and propagate those details to all the remaining slaves, saying that the who is the master and who are the slaves now. And ASA1 comes back and it wants to reclaim its master. So once it reclaims its master, again the director's job is to inform the ASA saying that you have to go back to the slave as master is back, and it will also inform the remaining unit that the who is the master and who is the slave. Now coming to this aggregation of that one, so I have to, in order to do the load balancing, I need to do something known as a interface mode as a span mode. So I have to change the interface mode as a span mode in order to get that load balancing enabled. So if you say that interface is so and so in the mode span mode, then only the load balancing will be enabled. Otherwise, it won't be enabled. So it will not allow you to configure the clustering in first place. All right, so let's go ahead and get the devices. So let's get the switch. So there is no configuration on any of the devices, so I'm going to configure it from the scratch. Now this time I will do the same thing. Configuration is like the HTTP server as the port number 80. So first let's go ahead and configure the inside outside and the DMZ. So I will go to the inside and I will say that config the interface E0/0, IP address will be 10.0.2.1. No shut interface loopback 0, IP address will be 172.168.1.1. And for the routing protocol, I will use the router OSPF1 and network will be 10.0.2.0 and the wildcard mask area will be number 1. So what I will do, I will just type in here. So area will be 1 for this one and area will be 2 for this one and area will be 0 for the outside. So outside is acting as like a backbone. So now I will also type in here OSPF and also I will type in the cluster link as the 100.0.0. And also the management should be 150.1.7.0. And I'm going to use this one as the same thing, 31 and 32. All right, so let's get back here. So I will say that area 1 and network 172.168.1.0, 0.0.0 and area 1 and exit and right. Let's go to the DMZ now. DMZ config the interface E0/0 IP address will be 10.0.3.1. No shut interface loopback 0 IP address will be 172.162.1. And router OSPF1 network will be 10.0.3.0. Area 2 and network 172.168.2.0. Area 2. And I want to make this one as the HTTP server. Same thing, IP HTTP server and IP HTTP authentication will be local. Username will be Cisco with privilege 15 and password will be Cisco. That's it. I'm just enabling the port number 80. IP HTTP server, IP HTTP authentication local. Username will be Cisco, privilege will be 15 and password will be Cisco, and that's it. So inside and DMZ is done. So let's go ahead and configure the outside. IP address will be 172.168.100.1. No shut. Interface E0/1. IP address will be 192.168.1.1. And interface E0/1. IP address will, sorry, interface E0/2. IP address will be 192.168.2.1. Okay, that sounds good now. I will say that router OSPF1 network will be 172.168.100.0, area 0, and network 192.168.1.0, area 0, and network 192.168.2.0, area 0. That's all done. So let's go ahead and configure our clustering now. So before we do anything, I will go ahead and config the hostname will be ASA1, save it, and I will go to the ASA2 config the hostname will be ASA2 and save the config. So before I go ahead and do any configuration, I need to enable E2 as no shut, and I will do the same thing, interface E2 as no shut. The first thing is that no shut the cluster link. Next, I said that the cluster interface mode must be span. So I will say that cluster interface mode will be span. So this is very much important. So I will do the same thing, copy that one, enter, that's it. Now is the cluster configuration. Let's begin with that one. So I will say that cluster group CLU, just creating a group, cluster group CLU. And I'm saying that local unit will be ASA1, and the cluster interface I'm going to use as E2, which has an IP address of 100.0.0.1 to 55.255.0. And I want to make this unit as a primary. So this will be the priority number 1. So still I did not enable the cluster. I just defined the group. I defined the who is the local unit, and I defined the interface. What is the cluster interface and the IP address for it. Do the same thing over here. Cluster group CLU. Local unit will be ASA2 and cluster interface will be E2. IP address will be 100.0.0.2. And here I will say that priority will be 0. Now I'm giving the priority because I just, this is a lab. So I just want ASA1 to be the master every time and ASA2 to be the slave. All right. After that, I will say that enable and click on yes. And again, type in enable one more time and next. Here I will say that enable as slave. I am forcing the ASA2 to be the slave by default, but still it will run the election. So if I say that show cluster info, you see that still it will run the election. And after running the election, ASA1 will become the master and ASA2 will become the slave. So now this will take at least 2 minutes time over here on the lab. But on the physical device, again, you have to wait until the election has been done. Next, until that has been done, so let's go ahead and do the natting also. Let's decide as usual. That should be 17.16.1.1. And here it should be 17.16.2.1. And I need to provide the route. So I will go ahead and go to the outside. And I will say that IP route 17.16.1.1. That should be 172.168.100.254. Now you see that this time both the routes I am pointing towards the one IP address, that is the outside interface. and save it. So in the context, you do have two different interfaces, but here on the clustering, you have only one interface as an outside. And let's see. So we have to wait until the um, cluster triggers. So it will take at least 2 to 3 minutes. All right. So after a while, it started the configuration, and you see that it became from disabled to master now. And the configuration was started, and it was also synchronized. If I say that show cluster info, so it's still doing the synchronization. After a while, it should show me that this is the I am the master and this other device is the slave. Now let's go ahead and configure these four interfaces as an aggregate those four interfaces, that is E01. So to do that one, first what I will do is that I will say interface port channel 1, port channel span cluster. So basically I'm creating a port channel on the ASA virtual interface, and that interface I am assigning it to the cluster so that it will participate. And next, what I am going to do is that interface E0, and I'm going to say that channel group 1 mode will be active and no shut. Interface E1, channel group 1 mode will be active and no shut. That's it. You no need to do anything on the ASA2. I just did the configuration on the ASA1 and it should be reflected back. Now, currently on the ASAs, I am running these interfaces as the port channel, but on the other side on the switch, these interfaces are not running as a port channel, which I have to fix it now. I did no configuration, so there are no VLANs, nothing. So if to say that config T, I have to create a VLAN from 2 to 4, 2, 3, and 4. And I have to say interface E1/1, which is going to the inside, that is VLAN number 2, switchboard mode access, VLAN number 2, and no shut. Interface 1/2, which is going at the bottom, switchboard mode access, VLAN number 3, and no shut. Interface E1/0, which is going to the outside, switchboard mode access, VLAN number 4, and no shut. That's it. Now I have to create these four links as a port channel. So what I have to do is that interface range, interface port channel 1, switchport trunk encapsulation dot 1Q, switchport mode, trunk, and notion. So I also created a virtual port channel interface on my switch, and I have made that port channel as the interface as the trunk link, because I'm going to create the sub interfaces on the ASA, and ASA is going to tag that traffic with the VLANs. So that's the reason I made my port channel as the trunk interface. Now I want those port channel to be I want the interfaces to be participating in the port channel, though interfaces will be E0/0, 1, 2, and 3. So what I have to do, interface range E0/0 to 3. First, I have to make these interfaces as a trunk port. So because it has to match the configuration of your port channel before you ask the interface to participate in the port channeling. So switch port trunk encapsulation dot 1Q, switch port mode trunk, and no shut. So all the interfaces should shut down and should come back on. And after that, I will say that channel group 1 mode will be active and no shut, and exit. Now ASA 1 and 2, these four links are going on participating in the port channel. So other interfaces, the switch interfaces were not participating in the port channel. So that's the reason interfaces will be under the suspended mode. So now the switches interfaces are participating on the port channel. So you see that the port channel came up. And if I say that show ether channel summary, and now here you see that I do have P after all the interfaces. So if I scroll up and if I see what do you mean by P, bundle into the port channel. So basically it says that all the four links have been now aggregated as a one logical link into the port channel. And now I can go ahead on the ASA1, and now I can create the sub interfaces and do the configuration. Now let's create port channel 1.1 that should be assigned to VLAN number 2, which is going to the inside. I will say name if will be inside, and IP address will be 10.0.2.254. And exit. Interface port channel 1.2, VLAN number will be 3, name if will be DMZ, and security level will be 50. IP address should be 10.0.3.254. Now here, if you see that I'm not assigning any standby IP addresses, nothing is been assigned. Next, interface port channel 1.3, VLAN number will be 4, name if will be outside, and IP address should be 172.168.100.254. Right, and let's do the ping first. So that should be 10.0.2.1 and 10.0.3.1 and ping 172.168.100.1. Next, let's configure the OSPF now. Router OSPF1 network will be 10.0.2.0, 255.255.0. Area will be number 1. Now, on the routers, we have used the wildcard mask. Here, we are using the actual subnet. So be careful in configuring that one. And area number 1, if you see that inside is area number 1. And if I go ahead and do the 3.0 to 55.255.0, area number will be 2, and network 172.168.100.0, area will be 0, and exit. All right, so at this moment, I have configured the routing protocol, that is the OSPF, and the election should start, and neighborship should be formed. So you see that neighborship is formed. And if I go to the outside, this neighborship is formed. And now if I say that show route, and I should get all the routes, that is 1.1, and also I should get the 192. So if I say that do show IP interface brief, okay, still these two routes I'm not seeing on the ASA right now. That is because the other side is still not on, I think. Or let me check, do show run section OSPF. Right. Anyhow, I am advertising, that should be good. So let's start these devices so that we see the IP addresses. Okay, this one came back. That's all good. Let's see this one also comes back or not. Yep, this time both of them came back. That's fantastic. All right, so let's see now if I get the routes or not. Yep, I got the routes now. So once I turn on the PCs, all the routes came in. Now, the other thing is that I want to allow PC1 to be communicating with inside server only, and PC2 should be able to communicate with the DMZ server only. So let's create the access list now. Access list, I will say that server permit TCP 192.168.1.0 to the host 172.168.1.1 in equation port number 80. Same thing, access list server permit TCP 192.168.2.0 to the host 172.168.2.1 in equation 80. Next, access group server in interface outside. Okay, so that's all done now. I have created the access list and I have allowed the traffic. So access list, and that should be good. So save it, save the configuration. Now that is all good, but the other requirement was that I need to do the netting so that the outside, the PCs from the remote, I don't want them to see the actual, want to know them the actual, what do you say, IP. So first I will create the two objects which will be well, hosting the, what do we say, objects will be assigned as IP address 17.16.1.1 and 2.1. So I will say that object network inside host will be 17.16.1.1, and object network DMZ, I will just select DM. Host will be 17.16.2.1 exit. Next, object network inside host, actual host, that is 172.16.1.1. I want to NAT this host from the inside to outside with the static INS. Next, object network DMZ, actual host will be 172.168.2.1. I want to NAT this one from DMZ to outside. Static will be DM, and exit and save the config. So at this moment, all should be done. So let's check the cluster config also. Show cluster info, and you see that in the state of master and the slave. But if I say that show OSPF neighbors, and you see that I am ASAs are acting as a DR. But if I go to the topology, ASs are acting as a border routers, but over here there are designated routers. So we have to change that behavior. So ASA should be a border router. We have to make it. So how to make the ASA as a border router? So clear IP OSPF process. So this is the command. So do clear the process, and I will copy this one and say yes, and it should reset the neighborship now. I will do the same thing and I will say yes. And now it is down. It will come back again. Do the same thing on the router. Do clear IP OSPF process and say yes. So all the neighborship should go down, and after that it will form the neighborship again. And if I see back here, my ASA now became the border route. So this makes sense now because ASA is the one which is going to uh, communicate between the different areas. So now the configuration is right. So I will say save it. So now all the things are good and in place. So let's go ahead and do the verification now. Let's go to PC1. That should be communicating to, let's assign the IP address first. That should be IP address add 192.168.1.2/24 day VTH 0, and IP route add default via 192.168.1.1. Ping 192.168.1.1. Default is pinging, and ping 172.168.100.254. That is also pinging. That's fantastic. So let's go ahead here, and I will say 17.16.1.1. I should be allowed, and the traffic is allowed. It's all good. And you see that. Now, if I try to access 17.16.2.1, that should be blocked. And even if I try to ping my inside server, that should also be blocked. So my access list is working fine. So let's close this one. Let's go back to the AS PC2 and assign the IP address first. That should be IP address add 192.168.2.2/24 Dave ETH 0, and IP route add default via 192.168.2.1. And if I say ping 192.168.2.1, I should be able to ping. And if I say ping 172.168.100.254, I should be able to ping. So let's go back here, and I will say that 17.16.2.1, I am able to get the access for the DMZ server. So if I say show IP HTTP server history, see that I'm able to access. That's all good. Fantastic. But the same thing, if I go back here and I will say that 17.16.1.1, access should not be allowed. And if I try to ping the DMZ server 17.16.2.1, still it should not allow. And now let's go back to the ASA now. On the ASA, if I say that show access list and you see that I do have a hit count, that means the traffic has been hit and we are able to communicate. Okay, so that was the clustering. I hope this was informative for you and thank you.